Hello, everybody. Today we're going to be dissecting Shai-Hulud, which is a supply chain worm. And if that means nothing to you right now, I'm hoping by the end of the talk, all will become very clear. But first of all, who am I? My name's Scott McCracken. I'm a principal solutions engineer at Wiz, now part of Google. And my main focus areas are all around kind of threat detection and response and supply chain security. But I've got a background in kind of development, DevOps engineering, platform engineering, so these supply chain worms kind of cross every single part of my career so far. And I'm based down in Brighton, but I spend most of my time that I can trying to escape city life and get up to, I guess, migrate up north, either to Scotland or to the Lake District, where I try and get outside as much as possible. And as you can see by the little guy on my back, I've recently got a puppy as well, so I always try and show a little close-up of him, because people seem to prefer looking at him than looking at me. Unfortunately, he's not here today. Right, before we get into supply chain attacks, right, just a little bit of background. Open source software, it's amazing, right? It's written by millions. It underpins fundamentally every part of modern source software development. Out of interest, I'll try and do a bit of audience participation, see how that goes. Who uses open source software? I'd expect pretty much everyone. Is there anyone that writes open source software? Awesome. Couple. Nice. And is there anyone that's heard of Shai-Hulud? Quite a few. OK, awesome. So yeah, open source software, like I was saying, it's basically grown into this massive interconnected supply chain of dependencies, right? So people write software, they push it to a public registry, people start pulling that code down and running it, and it enables us to accelerate kind of software delivery. We've grown to love it, and we've grown to trust it. But fundamentally, attackers have really started to abuse that trust. And we've seen over the last kind of couple of years that these have really exploded when we're looking at supply chain attacks recently. In fact, just if you think about the second half of last year versus the first half of this year, we've seen that over double in the amount of incidents, high-profile incidents that we're dealing with at Wiz. So Shai-Hulud, what is Shai-Hulud? Shai-Hulud is a self-propagating worm. For those of you that have seen the Dune films, it's named after a worm in the Dune films because it burrows underground. I've not actually seen it, so the reference is a bit lost on me. I should definitely watch it, given that I'm doing talks about it. But yeah, it's essentially a supply chain worm, right? It's malware that lives in the Node ecosystem. So when people install it, it does all kinds of malicious activity. And it's quite specific in what it's want. It's this team called Team PCP that are delivering this malware. And it's quite specific in the kind of credentials it's looking for. It's not just looking for kind of usernames and passwords necessarily. It's looking for cloud credentials. That's a big part of its attack. When you look at the code that it's executing, it's very, very interested to find all cloud credentials so that they can use them externally. Once they've got them, they don't need any kind of network activity. These can often be used publicly. But it's also, as we'll see, very interested in GitHub tokens and NPM authentication tokens so that it can carry on its attack. If it doesn't find these, it also just loves to cause chaos. And the impact has been massive. There's been multiple waves of Shai-Hulud. So we saw quite a few of them last year. And just the second wave alone kind of impacted over a third of the Fortune 100 companies. It's also impacting a huge amount of packages, right? So it manages to spread across the ecosystem very quickly. 700 packages might not sound like a massive amount. When they're being downloaded by millions and millions of people, it's very, very easy to see how quickly this can spread. In one day alone, November the 24th, we saw that there was around about 25,000 public repos published from Shai-Hulud, and we'll see shortly why that was a problem. And it ruined Christmas for a lot of people. December the 24th to December the 26th, a supply chain incident happened that was because of credentials thought to have been found in Shai-Hulud. And they basically managed to overtake Trust Wallet's browser extension, and off the back of here, they were then able to steal $8.5 million worth of cryptocurrency. So let's dive into what this is looking like, and to do so, we're going to introduce Dave. Dave is a software engineer who loves writing code. He works in a couple of different ways. He works for a fintech bank, and he also gives back to the open source community by publishing software for everyone to use as well. Dave is a happy dev. He uses GitHub. He relies on GitHub for a lot of his work, like so many great developers do. They're pushing all of his code to GitHub. He uses it for security scanning. He uses it for automation. He uses it to deploy all of his applications. So when Dave is making an update to his code base, he will run something like an npm install. That's essentially going to go off to the Node package registry and say, give me a bit of code to sort of like give me an open source package that I can start using. When he runs that, he doesn't realize this yet, but this has essentially triggered Shai-Hulud to start coming in. And Shai-Hulud is parachuting down, looking quite happy in his sunglasses, and it's going to start running some malware. And what we've found is these are very, very impactful at kind of avoiding modern detection. So modern, like a lot of the EDRs and stuff may miss Shai-Hulud, because to a lot of people, this just looks like normal developer activity. And we'll see exactly what that is shortly. And then when Dave's developing, he realizes, oh, the news has hit. I see this supply chain worm. This sounds pretty nasty. I should probably do something about it. So he goes, oh, God, right, I need to get rid of that. I've realized that I should rotate all my secrets off the back of it. I should probably update all my dependencies, remove all of this stuff from my file system. And he's also noticed that there's a repo that he's got access to. And he's not familiar with it. It doesn't actually contain that much this time. So he's like, right, I'm just going to make that private again and get on with my life. So now Dave is back. He's loving life again, developing that software, rerunning his npm installs to get more software. And little does he know that Team PCP have managed to introduce, it's popped on a mustache to try and disguise itself, but it's fundamentally a variation of what we saw in the first wave. However, I don't know if it shows enough, but it's meant to have bulked out a bit here as well. It's also evolved, right? It's got a bit scarier, and what it does is also a bit scarier, as we will see. So it starts to execute, but Dave, again, doesn't really realize. He's like, oh, okay. And then more news hits, and he's like, oh, again? So he sees the news, and he goes, right, is this in any of the dependencies I use? Yes, this time it is again. So this time Dave's like, what's it done this time? And he's starting to panic. He's like, actually, this is looking quite a lot worse this time. So I know last time that I rotated all of my credentials, I removed this from my file system, and I was pretty much fine. So let's go and do that again. That was a good step last time. But this time, Shai-Hulud had better ideas. It didn't just stop there. It thought, right, if they try and disrupt me, I'm coming in with vengeance. I'm going to come back and I'm going to get Dave, as we will see. So what's really happened here? What we see with supply chain attacks is that they often follow a very similar methodology. We're talking about Shai-Hulud today, which is one of the most impactful that we've seen in the industry. But fundamentally, they often follow this same pattern, right? They get hold of a dependency. It's legitimate software. They update that software. And then when developers come to download it and install it, it can do stuff like secret scraping. And again, whilst Shai-Hulud then used GitHub to start doing more in this space, there's essentially some kind of exfil. So they all follow that similar pattern. And then when it comes to worms, they're very, very effective because they're looking for credentials that allow them to kind of get themselves back into the open source ecosystem so they can spread very quickly. Like I mentioned at the start, this wave saw 700 compromised packages. I think it's actually much closer to 800-900 now. But we've seen this multiple times, so this has happened quite a lot. So let's dive into each one of them steps, right? What's really happened within that? So first of all, there's the trusted entry point. So the trusted entry point is the way in, and that is the open source software that Dave relies on to do his job. When he runs npm install, what actually happens is that open source bit of software now contains what is known as a pre-install script. That pre-install script will run before the dependency itself has even been installed. So it allows the attackers to run malware prior to the actual legitimate bit of software being installed. And this is one of the evolutions that we saw between the first wave and the second wave. First of all, they were using post-install scripts, but they realized that if the package itself failed to download or failed to install, then it wouldn't actually run. So they thought, right, let's update it and use a pre-install script. And they found that that was much more effective because they were then able to get much wider in the environment. And what you'll see here is that pre-install script looks harmless. It runs node setup_bun.js. Bun, for anyone that's maybe not a Node developer, is a legitimate Node dependency. It's nothing that's been compromised in this case. There's nothing malicious about it. When it runs that package.json, it runs that setup_bun.js. That'll then do a couple of things. It'll basically say, what operating system am I running on? Mac, Linux, Windows? And then off the back of there, it will say, OK, so I'm running on Linux. I'm going to install bun for the Linux system. And again, nothing malicious has happened at this point. This looks, again, like normal developer activity. But then what it does, it uses the bun runtime to essentially execute bun_environment.js. And this is where it then becomes quite scary. So bun_environment.js was 10 megabytes or over 10 megabytes of obfuscated JavaScript code. And the interesting thing is it was quite intelligent on how it ran. So it wouldn't just kick off the same way on every single system. it would say, am I running on a laptop, or am I running in a CI environment? If I'm running on a laptop, I know that I've got time, so I can background myself. I don't even need to let anyone know that I'm running. I can just put myself in the background and run my scans and things without anyone being any the wiser. Continue to install the scripts, continue to make sure that Dave thinks he's actually got that legitimate bit of software on his file system. But if it's running on a GitHub runner or a CI system where developers kind of test their code and things like that, it's ephemeral quite often, right? So it's going to die very quickly, essentially. It's ephemeral infrastructure. So in this case, it'll run in the foreground. It'll run synchronously to make sure that it can carry out its attack before it's essentially been killed. And what it will do as part of that, so once it's figured out how it's going to run, it's then going to look for a lot of information. And again, like I mentioned at the start, it really likes cloud credentials, but it's looking for all the system information, what operating systems am I running on, et cetera. It's also looking for environment variables. So many developers store secrets, cloud secrets as environment variables. If it can pick all of them up and ship them back to themselves, then they've got a lot more secrets. It also uses TruffleHog. TruffleHog, for anyone that's not seen it, is a legitimate open source tool as well that you can use for secret scanning. So it will essentially download TruffleHog and run a TruffleHog file system scan, and TruffleHog can find a bunch of secrets quite often. But then it's also got some pretty specific bits within this payload. So it will look for all of the kind of common cloud locations, .aws credentials, GCP, Azure, et cetera. Get all of them, and if it realizes that it's running on a container, it'll try and break out of that container and get the host credentials as well, if it can. And then it really, really wants GitHub tokens and NPM tokens. And why is it so interested with GitHub tokens? It's because GitHub tokens often allow the attackers to get access to a lot more than just Dave's secrets, right? So this, in my opinion, is one of the most terrifying things about this attack. It didn't just stop at Dave's machine. If it found a secret that Dave had that was a GitHub token, it would say, what repos does Dave have access to? And then every single repo that Dave had write access to, it would create a branch called add-linter-workflow. Add-linter-workflow, very normal-looking branch for most people. They would just think Dave is adding a linter. And it would create a workflow called formatter 123456789.yaml. And the interesting thing about this is it ran on a GitHub managed node. So it worked basically every single time they spun it up. It wasn't dependent on any infrastructure that Dave had. And it would use this runner to essentially scrape every single secret from every single GitHub repo that Dave has access to. So now it's not just Dave's secrets, it's every single secret that Dave has access to, or every single GitHub repo that Dave has access to. It would get all of them secrets as well. It would then publish that as an artifact, and it would re-download that back onto Dave's machine. And off the back of that, it wouldn't just stop there. It wanted to use this secret for additional things. So like I mentioned, it really wanted GitHub secrets, because it would also use them to do the exfil of these credentials as well. So they would create a public repo with a random UUID using Dave's own credentials. And the interesting thing about this is that it bypasses pretty much any kind of telemetry that you're going to look at, right? Because it's Dave, he's pushing to GitHub, he always does that. From a network point of view, there's nothing that interesting there. It's normal activity for him. So they thought, if I can use Dave's credentials to give us public access to that data, then great, it's going to bypass most kind of security tooling. So that's one of the reasons it was so effective. And like I mentioned, we saw 25,000 of these repos in one day, 24th of November. And then they continued to kind of go on like that, 200 to 400 repos roughly a day for quite some time. And what they contained in that public repo was all of the secrets that Dave had access to. So his cloud secrets, his environment, his every single one from them, GitHub actions that it's used as well, that it's downloaded from that formatting artifact. But then the next really clever and scary part of this attack is that it also then went on to create what I think was kind of the first time we had seen an attack like this. It created a backdoor back into Dave's machine. So it was like, I want now not to just have access via the malware that I've already installed. Oh, sorry, back one. Oh. So yeah, it would essentially create this backdoor, and that backdoor would then allow anyone with public GitHub access, so basically anyone in the world, access to Dave's machine via GitHub comments. So if you came into a GitHub discussion on that repo that is now public, and type into the discussions thread, you can essentially execute a reverse shell back into Dave's machine because it's registered Dave as a self-hosted runner. And it does that, or tries to do it at least, with root privileges as well. So then now, not only does the attacker have all of Dave's secrets, all of them GitHub secrets, it's now got a backdoor back into Dave's machine at any point they want. But not only for them, for basically anyone in the world, right? So it's public. Anyone in the world can come and write a comment. And again, it didn't just want to stop there, it wanted more. So it wanted NPM tokens, it wanted to spread itself, and this is where it became so widespread. If it found Dave as an open source developer, it was like, right, Dave has write permissions back to NPM. I'm going to append myself back into Dave's beloved open source tooling, and I'm going to make Dave now part of this attack as well. I'm going to update what he runs, so now every time someone else downloads the code that he writes, it's going to have that malicious dependency. And this is how they've become so widespread. And at this point, again, Dave, you can see he's got his hands on his head, he's freaking out a bit. And that first time, the first iteration that you saw Shai-Hulud, he just cleared his secrets. Like, he rotated them, and that was great. It fixed most of the problem. However, this time, what the attacker actually did is they put a little service into Dave's laptop that would basically ping, using them GitHub credentials and NPM tokens that he's got. It would just say, do I still have access? Do I still have access? Do I still have access? If they revoked that access, it would just start to wipe all of the data on Dave's machine. So rather than just leaving it there, so many people would just, I've got the credentials, whatever, let them rotate their secrets. It runs a command called shred, which goes through every single writable part of Dave's file system, which essentially overwrites the pointers on the file system so you can't really recover it. And then starts to shred all of that data as well. So it's not just removing it, it's actually pretty effective in shredding it. So what is Dave doing about this? Dave is back hard at work because there was quite a lot that went wrong. And the thing about these supply chain attacks, they follow similar patterns, and the reason that they've become so prevalent is that so much of this stuff goes unnoticed from a lot of kind of traditional tooling. So we need to make sure that we're building in the right safeguards in the right places across not just Dave's laptop, but companies as well, to make sure that we can deal with these supply chain attacks, because they really can be quite nasty. So first of all, he's removing the malware from the system, and to do that, you can look at so many of the blog posts that are out there. Wiz will publish one to say, right, here's what your next step should be. He's then going to go through, rotate all of his credentials, but very importantly as well, every single credential that this could have possibly touched. So he now needs to figure out, okay, this is all of the GitHub repos I've got access to. They've all got secrets in. Let's go through and rotate all of them as well. And now he's going to go and add some safeguards in place. He's going to first of all make sure he's pinning his dependencies, so when he does npm install, it doesn't just grab the latest one, it will grab a specific version. He's also going to add a -- ignore script, and that is then making sure that if one of them dependencies have a pre-installed script in it, they're not just going to run by default, right? So you can kind of review them and make sure that these scripts aren't running automatically. The most effective kind of command that we've seen to make sure that you're not at risk from these is adding dependency cooldowns as well. So a lot of package managers and centralized artifact registries and things like that now are starting to support a dependency cooldown where you can basically say only get that package if it's at least 7 days old. And we've seen that can reduce risk by roughly 90%. He's also going to make sure he's removing all of his credentials from his local workstation. Because I don't know about you, when I used to work as kind of a platform engineer, DevOps engineer, stuff like that, it was so convenient to just have admin. I would just, most companies don't realize it, I don't think, but at the same time, if you've got admin access, it makes your job a lot easier sometimes. But fundamentally, that is changing. Developer workstations, developer laptops are now becoming the primary point that these attacks are starting. So making sure that you don't have what you don't need on your laptop is very, very important. And one thing as well is that the open source communities and people like NPM, GitHub are also looking to fight back with this kind of stuff as well, right? So they've introduced some changes that allow NPM developers to have like staging environments and then only approve packages if they type in a 2FO code and things like that. So Dave's setting all of that good stuff up in the background. He's also going to loop in his friendly cybersecurity team. Because fundamentally, this is not just a Dave problem, right? This is an organization-wide problem. This is an industry problem. We all need to work together to fix it. How do we do that? There's a lot of different things that we can start to do to reduce our risk for this. So one is making sure that you've got complete visibility across your entire estate. So that's everything that you're running in the cloud, everything that you're running on developer laptops, everything that you're running in CI, make sure you're aware exactly what's in your estate. So if one of these malicious dependencies get updated, you can say, this is this version, here is everywhere that it is within my organization. I now know where has been kind of impacted. Also, centrally controlling dependencies. So whether or not it's some secured developer gateway or Artifactory, whatever it is, make sure the developers are pulling from a centralized package manager. And this allows you to centrally enforce some of that controls as well. So you can say, don't just pull the latest, make sure we've at least run some scans on it to ensure that developers are at least installing things that you know about. And then monitor your cloud audit logs is a really important one as well, right? We look at these secrets, and a lot of the secrets that have been exfiltrated are cloud secrets. So you can use the type of secrets that they're accessing and stealing to understand what cloud audit logs you need to monitor, right? They're stealing AWS, GCP, Azure credentials. They're also loving Kubernetes config files as well. So making sure that you've got CloudTrail logs or Kubernetes audit logs or GCP audit logs, etc. Monitored allows you to make sure that you can see these attacks if they're using them credentials down the line. Because what we have found is that so many secrets are out there. Team PCP must have access to thousands of secrets, haven't been rotated, and organizations have no idea that they've been exfiltrated either. So if they've been exfiltrated, all of these safeguarding that you want to put in place, unless you rotate them credentials, isn't necessarily going to help. You need to make sure you're monitoring them cloud audit logs to say these are in use in some unusual way. The next thing as well is monitoring the runtime. So making sure that you get visibility into things like CI runners. It's often overlooked by security teams, but we could see, as that diagram on the right there shows, that 77% of the kind of successful attacks that we saw from Shai-Hulud 2 was on CI/CD runners. So making sure that you can identify if they're happening and you can collect the right forensic evidence off the back of it is really, really key as well. And then, of course, this has always been best practice, but just make sure you're centralizing secrets management. Reduce the blast radius of all of your secrets and understand that blast radius as well, right? Everyone's a developer now that AI has come along, but if you have someone in the marketing department building an app because they find it fun, but they don't have any credentials at all and they get impacted by Shai-Hulud, it's not as important as maybe one of the production or platform engineers that have been impacted by this that then need to go and rotate their credentials. Whilst they're often the people that know what they're doing, at the same time, they're a much higher risk because they have a lot more access. So making sure you can understand that blast radius is really, really key. And then the last bit, which I've always found interesting, is kind of running tabletop scenarios. Do a hypothetical before this actually happens. They're so widespread now. Get all the relevant parties in a room and run through a tabletop exercise. I think one of the most impactful parts about this is you see so many security teams don't work together, especially in bigger organizations, right? We're seeing that this lands across AppSec, but also CorpSec or cloud security. So there's so many different domains in these that they don't necessarily talk to each other enough to really deal with supply chain attacks. So once all of this is in place, the next time it happens, which it did 2 weeks ago, KeyV and Cacheable, two of the really high-profile ones, were impacted. Millions of downloaders for these packages a couple of weeks ago. But when this happens, Dave can keep deving, right? He's not impacted by it. He's not even pulled that dependency because he's got that cooldown in place, so he can quite happily continue. And with that, I think I'm spot on time. So if there's any questions, happy to, yeah?
Kind of similar to this, I don't know if you've run into it, but how does the company manage? So there was a little bit ago with VS Code extensions being like, how is that managed when you have so many different people, especially with the advent of AI, creating code, vibe coding, but now they're like, ooh, VS Code is cool, look at all these extensions. How do you manage that in an enterprise so like that's not an attack vector? Do you have any thoughts on that?
I do, and I think it's a good point, right? Like, it's not just Node and Python dependencies, it is package managers and things like, it's VS Code extensions are a really high-profile attack vector. So we need some way to govern and control what developers are installing. There's a lot of companies, us included, that are like looking at exactly that problem because we find that there is no good solution for it on the market right now. But it's something that we've built recently. It is basically a governance around that, right? Because we need to make sure we can get A, visibility, and then B, control around that as well. So yeah, I don't have a perfect answer, but it's something that we're looking into and building at the same time, yeah.
Just something like a user awareness thing going, hey, maybe
that as well, right? Yeah. Yeah, 100%. 100%. Yeah.
Do you have any top tips for detections on
Yeah, and it's one really difficult thing is how do you identify what's malicious activity versus not malicious activity for runners. And when it comes to detection engineering in that point is still quite a difficult space, but there are certain things that you can look out for. So one of the really common ways about this, whether or not it's Python, Node, whatever, it's the post-installs, pre-install scripts, and you can detect when they're running. So that's the that's one part that you can look at. And then making sure that at least you have all of that telemetry coming in is really important as well. And then when you see these, especially the higher profile supply chain attacks, we often see that they reach out to very similar domains and use similar attacks. So build that into your detection pipelines. Like, for example, Light LLM, that was another high profile supply chain attack. They used like models.cloud.lightllm.com, looked legitimate, wasn't legitimate. So you can build all of that into your detection engineering as well. So look at we've got a lot of advice on the website as well for detection engineering in that space. Yep, sorry, the one back there.
What do we know about TPCP's post-exploitation? Like obviously there's been exfiltration with threads and so what else are they doing?
Yeah, it's a good question, and it's something that we're trying to track, and we've seen some of it like sold on the dark web, things like that. But we've not necessarily, I think that's one of the scary things about this, right, is that we don't know the full answer to that, because they have all of these credentials, maybe they're selling some of them, they've used them in some cases, but we've actually seen really basic stuff being done from some of them, so stuff like an STS get caller identity to just say, am I a valid credential, months after the attack. But they've not done anything else with them yet, so I think, yeah. So they've started to do things like that, but that's obviously just the beginning of something. So yeah, that's an interesting part. Yeah.
I'm just wondering if you guys are looking at some of the techniques from Miasma, for example, where it's using orphan commits to hide states hardware.
Yeah.
They seem to know Git better than I think even GitHub do.
Yeah. So I mean, using like commits and hiding commits in malware is now becoming very, very common, and like I think a lot of people in here would have seen, GitHub themselves are compromised. So it's clearly a problem for everyone. We are looking at it, like tracking GitHub audit logs, for example, is a really good way of making sure you've got the right detections in place for that. Because what you'll often see is they overwrite commits, old commits, force push things like that. So making sure you've got detection engineering into them GitHub audit logs is really key as well. Awesome. In that case, thank you very much, everyone. I'll be outside by the whiz stand, so thank you so much.